Today we're diving into one of the most common challenges in data preprocessing, handling missing values. Whether you're working with a small dataset or massive data warehouses, missing values can disrupt your analysis and lead to inaccurate results. Understanding why data goes missing and how to address it is crucial for any data professional. In this video, we'll explore the causes of missing data, the impact it can have, and practical strategies to handle it effectively. Let's start by understanding what missing values are and why they occur in the first place. Missing values refer to the absence of data in a dataset where a value is expected. This can happen for various reasons, such as errors during data collection, equipment malfunctions, or respondents skipping questions in surveys. Recognizing missing values is the first step in addressing them. They might appear as blanks, none, or other placeholders depending on the data source. Identifying these gaps early helps prevent problems later in your analysis. Next, let's look at the different types of missing data you might encounter. Not all missing data is the same. There are three main types: missing completely at random MCAR, missing at random MAR, and missing not at random MNAR. MCAR means the missingness is unrelated to any data, MAR means it's related to observed data, and MNAR means it's related to unobserved data. Understanding these types helps you choose the right handling method. Let's break down each type and see how they affect your preprocessing decision. Data can go missing for many reasons. Sometimes it's due to human error, like skipping a survey question. Other times, technical issues such as sensor failures or data corruption are to blame. In some cases, data is intentionally left out, perhaps for privacy reasons. Knowing the root cause helps you decide whether to fix, ignore, or remove the missing values. Now, let's see how missing data can impact your analysis if left untreated. Ignoring missing values can lead to biased results, reduced statistical power, and even invalid conclusions. For example, if a significant portion of your data is missing, your model might not generalize well. It's important to assess how much data is missing and whether it's concentrated in certain variables or spread throughout the dataset. Next, let's learn how to detect missing values in your data. Detecting missing values is a crucial first step. Most data analysis tools provide functions to identify missing entries, whether they appear as none, or blanks. Visualizations like heat maps can also help spot patterns of missingness. By understanding where and how much data is missing, you can plan your next steps more effectively. Let's move on to the strategies for handling these missing values. There are several ways to handle missing values, and the best method depends on your data and goals. Common approaches include removing missing data, imputing values, or using algorithms that can handle missingness. Each method has its pros and cons, and choosing the right one can make a big difference in your results. Let's start by looking at the simplest approach: removing missing data. One straightforward method is to remove rows or columns with missing values. This is effective when only a small portion of your data is missing and the rest is complete. However, if too much data is removed, you risk losing valuable information and introducing bias. Always check the proportion of missing data before deciding to drop it. Next, let's explore how to fill in missing values instead of removing them. Imputation means filling in missing values with estimated ones. The simplest methods use the mean, median, or mode of the available data. This approach works well for numerical or categorical data with a small amount of missingness. However, it can distort your data if used improperly. Let's look at each imputation method and when to use them. Mean imputation replaces missing values with the average of the available data. It's simple and fast, but it can reduce variability and may not be suitable if your data is skewed. Use mean imputation when the data is normally distributed and missingness is low. For skewed data, consider median imputation instead. Let's see how median imputation works. Median imputation uses the median value to fill in missing data. This method is more robust to outliers and works well for skewed distributions. It's especially useful when your data contains extreme values that could distort the mean. By using the median, you maintain the central tendency without being affected by outliers. Next, let's talk about mode imputation for categorical data. For categorical data, mode imputation is often the best choice. It replaces missing values with the most frequent category in the data. This method is simple and preserves the distribution of categories. However, if your data has many categories or the mode is not clear, it may not be as effective. Now let's look at more advanced imputation techniques. Beyond basic imputation, there are advanced methods like regression imputation, k-nearest neighbors, KNN, and multiple imputation. These techniques use relationships within the data to estimate missing values more accurately. While they require more computation and expertise, they can lead to better results, especially with larger or more complex datasets. Let's briefly introduce each advanced method. Regression imputation predicts missing values using other variables in the dataset. By building a regression model, you can estimate what the missing value would likely be based on the relationships in your data. This method works well when there are strong correlations between variables. However, it assumes that the relationships are linear and may not capture more complex patterns. Next, let's see how KNN imputation works. K-nearest neighbors KNN imputation fills in missing values by looking at the closest data points or neighbors in the dataset. It considers the similarity between rows to estimate what the missing value should be. KNN is flexible and can handle both numerical and categorical data. However, it can be computationally intensive for large datasets. Now, let's discuss multiple imputation. Multiple imputation creates several different plausible datasets by filling in missing values multiple times. Each dataset is analyzed separately, and the results are combined for a more robust estimate. This method accounts for the uncertainty of missing data and is widely used in research. It's more complex but provides better statistical validity. Next, let's look at algorithms that can handle missing data directly. Machine learning algorithms can handle missing values without imputation. For example, decision trees and random forests can split data even if some values are missing. These algorithms use surrogate splits or other techniques to make the best use of available data. This approach can save time and reduce the risk of introducing bias through imputation. Let's discuss when to use these algorithms. Choosing the right method depends on your data, the amount and type of missingness, and your analysis goals. For small amounts of missing data, simple imputation or removal may suffice. For larger or more complex datasets, advanced methods or algorithms that handle missingness directly are better. Always consider the impact on your results and validate your approach. Next, let's look at some best practices for handling missing value. Document your handling of missing values clearly. Always explore and visualize missingness before deciding on a method. Test different approaches and compare results to ensure your choice is sound. Communicate your decisions transparently, especially in collaborative projects. Now, let's review a real-world example to see these concepts in action. Imagine you're working with a healthcare dataset where some patient ages are missing. First, you assess the extent and type of missingness. If only a few ages are missing, mean or median imputation might be suitable. If many are missing, you might use regression or KNN imputation or even algorithms that handle missing data directly. This practical approach ensures your analysis remains accurate and reliable. Let's wrap up with a summary of key takeaways. Handling missing values is a vital part of data preprocessing. By understanding the types and causes of missing data, detecting them early, and choosing the right handling method, you can ensure your analysis is accurate and trustworthy. Remember to document your process, validate your choices, and stay flexible as new challenges arise. With these strategies, you'll be well equipped to tackle missing values in any dataset.